Okay, in this problem, our goal is to apply the mean value theorem for integrals to the function f of x equals cosine of x on the interval negative pi over 3 to pi over 3. So let's just give a quick recap of what the mean value theorem for integrals is saying. So let's look at in this case, we have the cosine function. So let's look at the graph of cosine of x. Do something like this. On the interval negative pi over 3 to pi over 3. So if we were to evaluate the definite integral of the cosine function on the interval negative pi over 3 to pi over 3, what it would give us is the area under the curve, the area bounded between the cosine function and the x-axis. Now what the mean value theorem is saying is that for whatever this area actually is, we could construct a rectangle with an equal area. So something like this. So there should be a rectangle that has the same area as what we would obtain with a definite integral. And so with the mean value theorem, it's an existential theorem. It's basically guarantees the existence of some value of c such that f of c is the height of that rectangle. So if you look at the mean value theorem, it's basically the formula for area of a rectangle. Area of a rectangle is base times height. So over here would be the area b minus a, that's our interval, so that's the base, and f of c, the y value, is the height. Okay, so let's go back over here to the actual problem. Okay, so f of c times b minus a, so this is a, this is b, so that would be pi over 3 minus a minus pi over 3, which would be 2 pi over 3. So f of c times b minus a should equal the area under the cosine function from negative pi over 3 to pi over 3. Cosine of x dx. Okay, so if we evaluate the definite integral, the antiderivative of the cosine function is the sine function, and we evaluate that at the limits of integration from negative pi over 3 to pi over 3. So we do sine of pi over 3 minus the sine of negative pi over 3. Okay, so sine of pi over 3 is root 3 over 2, and so we'd be minusing the sine of negative pi over 3, which would be a negative root 3 over 2, which would give us the square root of 3. All right, so now let's bring down the left-hand side of the equation. So f of c times 2 pi over 3 equals the square root of 3. And let's solve for f of c. Well, actually, we're going to solve for c. So if we bring the 2 pi over 3 to the other side, we'll have f of c is equal to 3 root 3 over 2 pi. And our f function is the cosine function, so f of c is the cosine of c, 3 root 3 over 2 pi. And if we solve for c, we have to eliminate the cosine function, so we could take the arc cosine of both sides, or the cosine inverse of both sides. So c should equal the arc cosine, or the cosine inverse, of 3 root 3 over 2 pi. Okay, I'm going to come over here on the right to Desmos to evaluate this. The cosine inverse of 3 times the square root of 3, all divided by 2 pi. Now, the directions say round to 4 decimal places. If we go back up to the original problem, round your answer to 4 decimal places. All right, so one value of C would be 0.5971, and that's radians. You could also answer this question in terms of degrees. That's not important. What is important, and which you could see by my rough sketch up here with the blue rectangle, there are 2 x values whose corresponding y value would be the height of the rectangle. And due to the symmetry of the cosine function, there's one positive c and there's one negative c. So there are 2 values of c in this problem, and they would be plus or minus 0.5971. So if we look back at the original problem, find the value or values of C and enter your answer as a comma-separated list. So we have 2 solutions here. C equals 0.5971 or negative 0.5971. Okay, that about does it for this problem.